Welcome to the first and the most important part of this course, which is the Map of SaaS. Here I'll show you how the entire SaaS machine works, including SEO and how you operate it professionally. We'll look at how it's built, the front end, the back end, and the entire validation, CI/CD pipelines, and the entire thing. So let's talk about what exactly I want you to take away from this video. So let me zoom in here and show you. The goal is to make you see the bigger picture. These concepts are from beginner to advanced. So basically, some of these concepts are actual software engineering level concepts which you learn in college or the degrees. But what I want you to understand is that we're not here to learn what exactly is, for example, Sentry. So I don't want you to understand, for example, what is CSRF course and all these things in detail, like how an engineer would understand. I want you to understand these words in plain English. For example, if someone says the authentication is done using JWTs or session, you don't need to understand the entire mechanism, the hash functions, and how the whole thing is done like mathematically. You just need to understand that if it's using this, or how are the permissions, what's authentication, what's authorization. You don't need to know in complete detail. You just need to know what it means in plain English. So let's look at the first thing, which is the front-end design. This is basically the visuals of a SaaS or software. So the first point is the onboarding flow. This isn't exactly the part of direct front-end design, but the onboarding flow is basically when a user sign up and then you ask the person some questions so you can figure out what exactly does the user want, and so you can optimize the product according to the liking of the users. So just wanted to get that out of the way. So now let's start with the main front-end design, like the entire thing. How does the whole thing work? What are the features and things you need to consider? So let's first talk about the UI UX, which is user interface and user experience. People group them together as part of UI UX, but they are separate things. So user interface is how each of the thing is crafted. Each element, how is it crafted? For example, let's look at Kalo data. So here you can say we have the buttons, we have the text, there's consistent design. The buttons are the same shape. There are two main kind of buttons here, one which has a background and one which doesn't, and this follows the same theme. And that's their pretty much how their brand design is. So now let's look at some other example. I'm going to see Buffer, which is a social media automation tool. So here you can see we have few buttons again. So the entire design is pretty consistent, and there are two kind of buttons here as well. One is with the same non-background, one with the green background, and you can see how they are of the same type and how the design is consistent overall. The next part is user experience. Which is how the product feels and how intuitive it is. For example, if you go on some website, if it's super unintuitive and you look at things and you can't figure out what's going on or how to do something, then it's really bad. And that's part of the UX. And the other thing you have to make sure is consistent design, which we just saw, that how the products have very similar and consistent design. The elements, the buttons they have some like button variants, they have text variants, they have consistent emoji using if they're using it, they have some kind of bento grid or whatever going on, which is pretty consistent. For example, here you can see the grid is there, then the entire page is going to have grids somewhere or the other. So the design part also includes how the font is stylized, how you want it. So for example, here they have chosen that whenever someone hovers over the text, it turns more wider, or the opacity of the grayscale increases. Now the last part is the elements, which are the individual elements of the user interface, which we saw the buttons and all of those things. Here they have some different kind of design and the design decisions they have made. Now let's look at how you can make all of this, the front end. So the traditional and the correct way, if you go by the entire process, like you want to start a SaaS, you want to go through the entire process of how you're going to structure things and do it professionally. And if you have time, this is not the fastest way, but this is how you actually do it. So you go to Figma and you design all your design in here. You make, and you also have to make your design for each type of viewport. For example, we have to make one for the desktop level, which is generally 1920 by 1080. And then there's iPhone or a smaller screen, the phones, the tablets. So So you have to make them for each of the viewports. So I'm going to show you one of the SaaS templates, which is the premium SaaS landing page. And here you can see they have done all of it. It's not, I don't think these are individual components. Yeah, these are images stitched together. So this is one way that you design individual components in Figma and you make a complete library of your SaaS and the product, how it's going to look. You make it in the assets and files and stuff, and then you assemble it, and then you go in Next.js or any frame or motion or whatever you're using, and you replicate that. That is one way. And now things are changing, things are getting fast. People are just releasing products after products. So what actually going on is there are pre-made templates. So what they do is they copy the pre-made components and they just use it in their SaaS and then they design it. So what they do is they copy the pre-made components and edit it to make it look and feel like it's their own product. So they don't design everything from scratch. So let me show you an example. So let's look at this ShadCN UI blocks, which is basically pre-crafted ShadCN and front-end elements. For example, if you want to add a hero section, you can go here and there'll be so many blocks pre-made for you. So you can just copy paste it. And there's every kind of block. So you can customize it later. Here you can see there's a 3D isometric hero. So you can just copy all of it, just change the text, change the buttons, and change the image for your own product, and you can get moving. And you can see here we have every kind of design. And there are many more sites like this. I have made an entire document for you, which you'll find in the course, of where you can get these pre-made components and different UI libraries. So now you understand how the front-end design is done and how the modern way to do it is that you just build the entire thing in one of the wireframing and design software, then you replicate it in your code, or if you're using a no-code tool or low-code tool. And the other is you just take the elements, copy them in your project, and brand them, basically. That's one of the way to say it. So now we have taken a look at the front-end design. So let's move on to the state management. So an important part of a working SaaS is how the state is managed. So let's look what exactly am I talking about. So when you look at the user interface and you look at each element, so for example, in ChatGPT, here you can see the search and all these buttons are different elements. In Creo, you have this button element and all these elements. So all of them have state. All of them don't necessarily need it. For example, there's no need to map the state of a button. You can call the hover a state, but it's not what we're talking about exactly. So the state is basically how the search and all of these things are stored. So there are two parts to the state of an application. One is local state, the other is global state. So let's first look at the local state. Local state is the state of an element or elements on a page, which is limited to that page only or that container. So let's look at ChatGPT, for example. You can see this chat element is on this main page. So whatever the state of this is, it is limited to this home page. It is not limited to anything else. So when you model the state of this page, you can just model it on the programming which is done on this page itself. So you don't have to have some global store where you can store all of this stuff. So let's look at how the global state management is done. Let me draw some things here so it makes it better. So for example, this is your web page and you have some elements, and imagine you have a search bar here. This is your search bar. So whatever you enter here is part of the state. You enter something here that goes into the state, but you don't need to store the state globally because it is just limited to this page and you don't even actually have to store it. When people refresh, things go away. So that will be part of the local state. And some things are part of the global state. For example, Amazon. So when you go to Amazon and you see the cart, no matter which page you go to, the cart is consistent and the data doesn't go away. For example, if you have 7 items in the cart, the items stay, they don't go away. So they're part of the global state. And let me give you another example of global state. If you look at these applications, Lovable, Bolt, and stuff, you'll see this chat bar is locally stored only. And even that till the page is not refreshed. For example, now I'm going to enter clone google.com. And now what I'm going to do is refresh this page. I refreshed it, and now you can see this stuff is still here, which means this field is stored in local storage or some kind of cookie or something. So it's not going away. Let me see in another product, which is bold.new. Let's try this here. Let's try this here. So I'm going to say clone google.com. And then what I'm going to do is refresh this page. And here you can see it goes away. So Lovable has made a design choice that whatever you enter in this chat, they're going to store it locally. So when you come back or you have some unfinished work and you refresh the page, by mistake, it doesn't go away. Save with ChatGPT. For example, if I say, how are you? I'm just going to write this, and then I'm going to refresh this page. And now you can see the page refreshed completely and it's still here. So these are different design choices, and state management is an important part of the front end. So till now, let's recap what we have learned till now to have things clear and not miss any points. So we have this website or web app, single page, multi-page, doesn't matter. There are many elements here. One element, I'm going to change the color, and then I'm going to make some more. I'll make this. This is another element, one more element, and then we have some search bar or some stuff. So this is our design. Then every element has its state. For some things we don't need it. For example, there is just some text. For some things we don't need the state. For the others, we need it. So let's see what we learned. First is a local state, that things have state locally on the same page, which doesn't affect the whole website. Then we saw the global state, which is, for example, the Amazon cart. The state of the cart is reflected across the website, no matter which page you go on. Then the state is stored. In bold, we saw the state is not stored. So you enter whatever, but you come back to the site after refreshing it, it goes away. So you have to store the state. Now there are a few ways to store the state. One is local storage, and the other is cookies. And it's mostly local storage. Some people do it in the cookies. And you can also sync the state with the server. For example, here in the Lovable app, if you enter something, now this element has a state of this. So this element holds all of these characters, and I refresh it. It's still here. It's holding it, but it's stored in the local storage. And how you can access local storage is by pressing F12 on your computer or clicking on the inspect button. You have to inspect the element, and you have to go to the application here, the application option. And here you can see there's a local storage. And now you can see we have the local storage here. So this is where the local state is stored if you store it. So now you can see there are so many options here, and one of these holds this. It's probably this chat input message. It might be one of these might be holding. Okay, there we have it. So this element create form has a local state, has the local state stored in this element, chat input, chat message, create form. So this is stored here. So let me even remove this. I'm just going to say, my name is Dorian. And now you can see they're storing it. So when the person comes back, even after refreshing the page, this is maintained. The local storage is maintained. And you can store many things. For example, you can store the theme preferences of people. So when they come back, you don't like randomly start with a light or dark theme. You can have them selected, for example, whatever they choose, and you can just store it here. So, and you can load the theme from this option. And they have stored many more things. And the other is cookies. The cookies can be accessed the same way, but they're not mainly stored in cookies. Cookies is used to store the other tokens and stuff. We're going to see it later. And now the other thing is you also have to sync data to server sometimes. For example, they have this form here. So syncing this in the server doesn't really matter. This is probably not going to be so important. Maybe they have it, maybe they don't. They have just stored it here, right? But what you can do is also sync this element, the local storage or this form element, to the server, which is seen in the Amazon cart. So you have a cart here. Whatever number you have here is actually stored locally in your computer, which is stored as a global state locally. It's kind of confusing if I see it now that there's no local state, there's local storage. So local state basically implies the state on the same page. It doesn't always need to have a local storage associated with it, but you get the idea. And then the server sync is about syncing your state with the server. The cart, Amazon cart, if you have 7 items, it's stored in the local storage as well, the server as well. You delete the local storage sometimes. For example, I think you can delete these things from here. You can see there's the delete key. If you delete this and refresh it, it's probably going to go away. So now you see it has gone away. So what does that mean is that they are not storing the state in the server. As I said earlier, this is not so important to them, so they just don't store it. They just put it here, which is here, but they don't store it in the server. But in case of Amazon, they have their state locally saved in some of these options here. If you open their site and fidget around, you'll find out. And they also sync it with the server because they don't want your step to go away. For example, if you open a mobile app of Amazon and you add some items to the cart, and then you come back to the web app and you see, oh, there is nothing in the cart. So that is how the server sync is utilized, that you can store the state in the server. So now we have seen the front-end design and the state management and how these things are coupled together. Let's go on to the next part, which is the authentication and authorization. So whatever application you're going to be making, it's probably going to have the sign in, sign up, and it's going to have a user workflow so people can use it. So there are 2 parts to it. These are the technical words, and I'll tell you why and how they're different. The first is authentication. So authentication is a process of verifying and adding users to our database and our project. And authorization is specific control over your application and rules, what the person can and cannot do. For example, if you have 2 options in your product, if you have an admin and a normal user, so authorization will be used to tell if they can do certain actions. For example, one of the word is RBAC. There are actually 3, ABAC, RBAC, and REBAC, but we just need to look at RBAC, which is the most important and used option. So this is the role-based access control. So what people can do based on their role. If there's an admin panel, a dashboard, normal users should not be able to access the dashboard, and the admin should. So we can do the authorization for that and have permissions. And authentication is basically adding people to our project. So let's first look at authentication. Authentication can be done in 2 main ways, which is the JWTs and sessions. So JWT is the JSON web token, and the session information that you're using the website. So let's look at a few examples and see how it's done. So let me open Lovable, and here you can see I signed in, right? So the JWTs and sessions are stored in the cookies. So whenever you make an account, you send a request to a server. Let's just make a drawing. So you make an account, you send information to a server. The server says, okay, you're good. And now it sends you back either a JWT, which is your token, and you can view it as like just any other token in a party, for example, that you are a member of this thing. And the other is sessions. Either you can return sessions, and the other is session. So let's look at Lovable, for example. Here I'm going to open its cookies and see lovable.dev, and let's examine it. And I'm going to make it smaller. And now you can see that they have so many things going on here. But let's try to find some word. There you go. So Lovable is using sessions, and this is the session ID. And the session refresh token and all that stuff. So this information, this is a special kind of JWT. So whatever starts with EY is a JSON web token. And you can actually decode it sometimes. So what I'm going to do is copy this and go to ChatGPT, and I'm going to say, decode this JWT. So let's see what exactly is stored in here. So this is encrypted. So the server knows this is not fake or anything malicious. And now you can see the first part is the header, then the payload, which contains the information, then the signature. And here you can see the information stored. So the header is basically the algorithm it's using, which is the RS-256. And then this is the payload. It contains when the token was created, when it's going to expire. So they use a session base. So the thing with sessions is what it gives you control over is that you can auto sign out users. You probably have seen some secure applications, for example, banks. So banks utilize sessions because JWTs are hard to revoke. Imagine you have a party of 10,000 people. This is a party, and you give access to 10,000 people here. You just give one after the other, and you give them badges, which are their JWTs. And then they do something crazy. They do something malicious. So now you can imagine how hard it is to crack to who's doing what. And even if you can track it, which is fairly easy to do, you can see which user is doing something wrong, but you cannot remove their JWT. Like it's hard to remove. Once you have issued it, it's just there. And there are other ways how you can like auto refresh it, reissue it after some times. For example, in super secure applications, they have expiration time of 5 minutes. So the JWTs expire every 5 minutes. So the person has to log in. But specifically in banks, they utilize sessions. So if you don't come to your bank homepage, so it auto logs you out, right? So in Lovable, you're using sessions, and here we also decode it, and you can see. So do you remember when we signed in? So let me do it again to show you. I'm gonna sign out and sign up. I'm just doing it just to show it to you. So when I click sign up, here you can see what are they using. You can see their tech stack. Oh no, it has auto signed me in. What I'm gonna do is copy this and make a private page, and then open this here to show you how you can reverse engineer websites and ideas to make your own. I'm going to click sign up here. So now I'm on the sign up page. So I'm going to click sign up with Google. Now you'll see this will appear. And now you can actually read these things to get some idea of how they're making it. So their app is called GPT Engineer. And this is the email. It's from the founders. And they're using Firebase for their backend, which we can infer from here. We just decoded their payload. So this is basically a timestamp issued at, and this is the expiration when it's gonna expire. And they have some time limit. You can make it 30 minutes, whatever you want. And this is the thing you're using. They have their database from Firebase. And these are the claims. There's more information that how is the email verified and stuff. And this is how the Lovable session is stored, and you can have your own session ID. And this is custom. So what I'm going to do now is I'm going to copy this other session ID and decode it. So let's see what we find out. Decode this, please. And now you can see there's more information. This time the header has the type of the session ID. Session ID is being sent in a JWT. This is some kind of ID, user ID or KID. We'll have to. This is the key ID. Okay, that makes sense. And this is the algorithm. And now you can see the payload contains all the information. It contains my name, my account's name specifically, the picture, the email verified, how was it issued, when was it issued, the time, the user ID, which the internal user ID which Lovable is using to store my account. So everybody has a separate user ID. So this is probably the sub information, like am I subscribed or not? I don't know. This is when was it created, and all the information. So they do it in a session, right? So we saw one of the ways to do it, that people come in, you get their email password or Google or GitHub or some kind of SSO, and then you make their account. You give them, they send you a request, you give them back their session. Now they are a user and you know what's going on. And sessions are basically stored in a database, but you should add Redis and caching to make it fast. Well, this is advanced stuff. We'll look at it later. And the other way to do authentication is JWTs, which is JSON Web Token. So here we saw their session is sent in a JWT, but the authentication itself is not being done in a JWT. Now I'll show you what it means. So let's open some other website. I'm going to use Bolt. I don't know what they're using, so let's find out. And now let's see. So I'm going to sign in using my account. Let's build app. So let's click F12 or inspect element. I'm going to do inspect element. And now I'm going to go to application. So do we have it here? There we go. We have application here. So now let's look at, so I don't think they store the form data as we saw. Let's look at the cookies or bold mail. Let's examine their cookies and what do we get here? Let's try to identify, okay, they are also using a session-based authentication. And this is the session ID. So this gets refreshed after some time. So let's see if GPT uses the normal, if GPT uses the JW keys. So I'm going to do is inspect element and go to application. And now you can see, okay, we're here. Okay, so GPT also uses sessions. So overall, sessions are the more secure way to build it. So it gives you more control so you can ban members. So we saw everything with the sessions. Let's try to find some application which uses JWT directly for their authentication. I tried it in Lovable, Bolt, Trail, Tempo, and GPT. All of them are using sessions, but I found Shortnoise, which uses super-based authentication directly. So this is a JWT. Here you can see there's the auth token and how it is. It's pretty similar to it looks similar to the sessions because both are stored in JWT, but backend is different. In the backend, in this way, the sessions are being created and sessions will be called off if the person is signed in and the session expires. They are going to be logged out. And this is how this whole thing works in the sessions tree. But in JWT, this is not the case. If the person is in, he's in. And if you want to implement the token rotations and all that stuff, that is a bit advanced. So if you want to learn, let me know. But you can just customize using normal options. For example, here we saw in Shortimize, they're using JWT auth. And you can also reverse engineer it more. For example, here it says SB. So if you have some experience in the field, you can probably guess this means Superbase. So you can see they're using Superbase authentication directly. They're not using some third-party library. And they're also using HJ session. And this is basically Hotjar. Hotjar is used for customer support and all that stuff. So they're using that. And these are the libraries. There are more. And this is Zoostan and Redux for safe management. We're going to be using Zoostan. So now we have seen this part, this section, the top and the left. So now let's go on to the payments. So if you're going to be selling your SaaS, you'll need a paywall. You can either go on the freemium model or fully paid. For example, all of these are freemium model. You can still use it, but after sometimes the tokens are going to end up, or they will probably allow like 2 messages a day or something. So that is premium model. And if you just want to limit everything, for example, Shortimize is fully premium. So there is no free option. So that is done using Stripe, Polar, or other stuff. And how this thing works in the background is you have your website, you have this page. The person buys some plan, they click on a button. They are taken to the vendor's checkout page, like Stripe or Polar. So you go on that page. The person enters their stuff, the information, they buy it, and this is done. So you have bought the item. So now what's going to do is store the information in its own session. For example, Stripe is going to store who's your user, but now you also have to send it back to your database so you know what's going on, because you have to keep track if the person is signed in and if he's a paid customer, when his access is getting removed, because if he's not continuing to pay for the product or he's found something else. So that is done using webhooks. So whenever you send the person to sign up on the application or like the Stripe or some other vendor page, if this gets accepted, like if this doesn't go through, then it's just going to send a webhook which says the thing didn't work, the person didn't pay, or there was some error with the card. But if this thing works, it's going to send through. Great. Now, this is stored in the database and you give access to the premium functions to this user. And you also track when this person joined, how long does he have, when he's going to go away, or is he going to continue to pay for the products. So that is done using webhooks. So you send all the information. Now, the next thing is, this is pretty advanced. So I'm just going to tell you what these words mean, which was our main challenge or our main reason for doing this. So WebSockets, gRPC, event-driven. So whenever you do something like an event-driven thing, imagine you want to make an image on GPT. Let's build this. I'm going to say create an image of a lion. So now this is an event-driven mechanism. So we have sent a request. So now in some computer, in some pipeline, things are going to be done. And then when it's done, it's going to send you back. So that is done using event-driven mechanisms, because this is not a one-time thing and it's not going to happen in an instant. For you have limited compute. Imagine you have a computer, you have your server, 1,000 people ask you to make an image. You cannot do it simultaneously. So you need to have a queue. So you'll do one first, then the other, and you can do some parallelization. You can do 2 or 3 of them together, but you cannot do all of them together because you have limited compute. So that's where the event-driven mechanism comes in. And WebSockets are used for connecting 2 things or 2 sites or database to a site in real time. So the REST API webhooks are pretty fast. The webhooks are faster than REST API, but the fastest is WebSocket because it opens duplex connection, which basically means you can have talk from both sides. So when you send a message, it just goes there, and then this person sends a message, this comes here. Same with the REST API and webhooks, but the WebSockets open a tunnel. So now you have a tunnel going through, and all the information is flowing through it. The other is coming from it. This is like a bidirectional water pipeline. And so that's where WebSockets is used, and gRPC is a bit different, but let me know if you want to learn all these things. I can help you with that if you're making the application which uses this. But now let's get back to our other topic. So these things won't be needed in most of the cases, most of your SaaS, especially when you're starting out, or even if you're building something complex. So let's look at the server and the storage. So backend, your computer, your server has 2 main things to do. One is the database, and the other is running the functions, the server actions, and all that stuff, and how the data is managed. So let's come this side and look at the database first. So there are 2 kinds of databases, SQL and NoSQL. So what a database is just a collection of rows and columns. You just make a table. For example, you make a user table. So you have a user, and then you say the first is the ID. So you can have like 1, 2, 3. Then you have the name. Then you can have their location, I guess, and their email, this, that. So that is all what a database is. And you can have many of these tables. You can have relationship. For example, you can say every user has a subscription. You can have a subscription table, and you can say the time when the person got the subscription, the card they're using, if you're storing it, and whatever else, right? So that's all the database is. But in NoSQL databases, this is not the case. So what SQL means is structured query language. And here you can see we have a structure here. We have tables, we have rows, we have columns. So in NoSQL, there is technically no structure. There are no rows and columns. The things are stored in key value pairs. So that means that you can store name, and then you can say Dorian. So that's the structure. You have a key value pair. And you'll do the same for the entire database. You'll have this, name that, person A, person B. That's how it's used. And this can be helpful in some application, but this is more structured, better, and will be sufficient for more of the things we do. Now, you understand what a database is. So we'll look at this side particularly. So now you understand what a database is. It is just a collection of rows and columns, and the collection of rows and columns is called a table. You can have many tables, and you have your database, right? So database consists of many tables, many rows, many columns. That is clear. But how do you interact with a database? Like, what do you say? Imagine if you want data. You want all the people. For example, if there are 4 people in my database called Dorian, there's Dorian 1, Dorian 2, Dorian 3, Dorian 4, and I want to ask my database, tell me all the names which have the first name as Dorian. So how would I tell it? So that is done by SQL or SQL or structured query language. You tell it. So this is like programming language, just like all the other programming language. And you can see how it looks. So I'm going to show you now. And there you go. We have our image. Pretty amazing. So let's see. I'm going to ask it, give me simple SQL command. Okay. So now I have some options to show you. So this is how the connection to a database is established and how you talk to a database. If you want imagine you have a employee table, you have a table named employee and you want to know name of every employee. Imagine you have a SaaS and you want to display the list of the employees. So this is how the backend function will be called. You'll write select star from employees, which basically means select all. Star means everything from the table. So this will return every data from the employee table. And now you have all the information from the employee. You can return all the columns, for example, here, and you can insert. The command to insert is insert into. And the into is basically to tell it which table we're going to use. And the values we're inserting is Alice, manager, 75,000, the salary. This is how our table looks. You can update the data, you can delete the data, you can create the table, and in the table you can tell it the type of data you want to store. You want to make an employee table. You want to make an ID, which will be an int, and it's the primary key. You can make a name, which would be a variable character, and the limit would be 100. So you cannot have a name longer than 100 characters. And you can do all of these things. And you can filter. So where is used for filtering? For example, if you have an employee table and you want to find out how many people are earning more than 50K, so you enter this where keyword. So this is how you talk to the database. But now things have changed. So back in the days, what would happen is you have your front end. This is your DB. You want to talk to the database. It's a SQL database, means there are so many tables, and SQL is the language we use. We want to display every employee. This is our web page. This sends a request to our database through the backend, and in the database, this command is run. Select all the employees, and then this database sends it to the backend. Backend sends it here, and then you display it. That's how the full flow looks in the background. And if you want to show the results, for example, people who are earning more than 50K, then you send that command, right? But now things have changed because writing these queries is tedious, and you have to write a query for each task, right? So you can imagine you have to write this for the entire SaaS, like each thing. So you want to retrieve every user, so you have this thing. You have to retrieve every something else from some other table, and then you have this command. So you have to write command for each of the thing, like 100 SQL queries. So there's a thing called ORMs, which is object relation managers. What they have done is abstracted away these tedious, simple query writing tasks. And I'll show you the example. Now show equivalent and Prisma. So Prisma is one of the ORMs. So this has abstracted away. So now we have information from the GPT. So this might look simple. You might be thinking, what's hard about writing 4 words? What's hard about writing these words? Like, what is so complex? But in large applications, these lines can be super long. Like you'll have this command, it will be like a page long command of what you want to do. And this gets super tedious. So we have ORMs to make it easy. And ORMs pretty much use English, it's pretty readable. Here you can see you have this same thing. And so you have the first command, which we saw above in SQL. We have done it using Prisma. What this does is it fetches all employees and store it in the constant all employees. And it is done using Prisma.employee, which is the table name. And then you say find many. What find many does, it returns all the things from that table. And you can even filter stuff. For example, you want the name and the salary of the person, not anything else from the table. You can say select this, and it's going to return that. You can insert data using the data command and using the create here. You can update using update here. And where is basically used to say uh, change whoever's name is Alice and change the data to this. And you can update many, you can remove, and you can do all this. So this, in these two examples, I think the difference is not the clearest. You can see this is as long as all these commands, but as the queries get bigger, this helps. But what it also does, it slows stuff down. So if you write these direct lines, it is faster to access the database compared to writing this Prisma stuff. But if you are running a SaaS, even with 1 million users, you should not have a problem and it will make your life easier. And the only people who use direct SQL queries and all this stuff is extremely large companies who write their queries manually, the big tech, the Microsoft. And if you have like 1 million users, you have some challenge, some queries taking super long. So what you can do is write a specific query. And when you use Prisma, it does not mean that every query has to go through Prisma. And if some query is slow, imagine you have a table called user. There are 1 million people in it. So let me make it here. You have a table. There are 1 million people. And then you want to find, you run a query that give me all the people whose names start with D. Their salary is more than 50K. They live in Washington or someplace, and some other information. And now you can see how this query gets long, right? This goes from this, one more filter. And now imagine you run this in Prisma. It will be fast, but now because your database and all the stuff is so big, it's going to be slow. It's going to take, like, for example, 5 seconds and 10 seconds, and you don't want your application to be slow. So what you can do is you can specifically write a query for your need. You can just write this raw query, and you can tell Prisma, so whenever this thing comes in, do not run your own stuff. Direct the person to my own manual query, and that's going to be, for example, 3 seconds, 2 seconds faster, right? So that is how this entire thing works on the database side. So now you have seen front end, you have seen state management, the authentication, the databases, and how what a database is simple collection of tables with data in it, the rows and columns. Then you have seen SQL, which is the structured query language, the language we use to talk to the database. Then you have seen the ORMs, which sit on top of the database, so you don't have to manually write queries. And that is what we have learned until now. So Supabase is a commonly used database online. So now hopefully you can see the concept and the bigger picture in simply plain English. Hopefully you can understand the machine. Oh, there's a front end, there's a server, there's a database. This connects to both. And it is a good practice to not connect the front end to the database. Imagine someone hacks something in the front end. So it should not go directly to the database, else they can mess things up. So you should make sure this always goes through this. So there's additional checks and balances, right? So all the communication should happen through this. And whatever you want from the database, you tell it to Prisma, which underneath writes the query. The query fetches the data. The data is passed from the backend to the front end, and we display the data. That is what we have learned until now. Even when the authentication is there, you have your authentication. Users make an account. The information is sent to the backend, which is stored in the database, and then the user is there. So whenever a person logs in, you check into your database through the backend, and you let it go through. If the person deletes their account, the query triggers the delete command in the database, and it's deleted. Perfect. So now let's look at a bit more on the server side. So what exactly is a server? Server is nothing but a program which runs on a computer, which does certain commands that you have told it to do. Imagine you have a function running, right? So the function is to create a user. So what this function will do, so you want to create a user, right? So you have a function here, and the function, you just tell it, you just write, I'm just going to write in plain English, which is more important for you to understand than code, which we'll see later. So the function is, whenever a person makes an account, what you should do is you should run some functions and you should run some validation. If it works, you should send the data to the database and create an account. That is basically the job of the server, right? It just runs some things. You can talk to it via REST APIs, and there are 4 types of REST APIs commands basically, which is the get, post, patch, and delete. And the webhooks are similar, and there's a difference between APIs and webhooks. So I'll tell you that. So API is simply a request which is triggered whenever you trigger. For example, if you have a button and when you program this button, you write a function underneath, like I showed you an example, you write a function, the backend function for this button, that whenever someone clicks this, run a REST API request to some server or application. So whenever you click this, a request is triggered and the function is done, or the API is sent. But webhooks are different. Webhooks are like listeners. So they're always listening 24/7. So whenever something happens, they send this request. So now you can see the difference. The REST API has to be triggered. Webhooks trigger based on something they're listening. So one of the examples I'll tell you is, for example, you have a chatbot. So imagine you have a chatbot, Instagram chatbot. So you have a message here. So webhook will constantly be listening here. So whenever someone sends you a message, the webhook triggers and the bot sends a reply. This is an example of webhook. Imagine if it was REST API. It wouldn't possibly work. Maybe you'll have to add a button or something for the person to click so you can trigger some functions. But this is the use of webhooks, right? And we're going to be using webhooks a lot for anything agents. Now, the next thing is form data. So now let's talk about form data here. So whatever input field you see, for example, you can add text here. You can add text here, here, and the sign up form, the sign in form. So when you sign up, you have this field here. So this is simply a text box, right? But in the backend, imagine if you have a form, someone sends you a form, right? So I'm just going to draw here. Maybe I'll just zoom in. So imagine someone sends you a form. You have fields, you have name, password. So once someone sends you that, you should not directly store it. Why? Because there might be some malicious commands running. Imagine someone sends you an email which is not correct, like without an at. So I'll say this, and now you can see enter a valid email, right? So this is done using the form validation. So in the background, it's checking with a function, right? So when you enter something here, it's going and checking its validation library or whatever it's using. It's checking. And so then it's just checking with that thing to see if the enter data is correct. Imagine in the backend, you define that the email should have an @ sign. The name should not be longer than 30 words. And so these forms check that in the backend. For example, until I add an @ and some domain.com, it's going to say it's invalid, right? So when I'm entering this name, so this request is being sent to the server, which checks with some function that whatever is this person entering, is this correct? Or is this what we want him to enter, right? And it just checks it and sends it back. And you can also check it using inspect element. So I'm going to click F12. I'm going to click inspect element. And now I have it here. And then you go to the network tab. And now when I enter this, there you go. So it made a request, and you can probably see it sent the payload, right? Okay, so it sent the payload. It sent this request. So if you decode this payload, it is encoded and encrypted. You will see it sent this. It sent FEF, right? So whenever we enter something, it's sending it to the backend, verifying if it's correct, and then sending it to us, right? So if I enter gmail.com, it's sent again, and then it said log, probably it's gonna enter that it's correct. It's also sending the information. For example, I'm using a PC. The environment is production, the country, browser I'm using. So it's basically logging everything about me on this website. And this is the same. This is what exactly the form validation means. And there are different libraries like Zod you can use to do it, which I'm going to show you in this program. And you'll learn everything end to end. And now moving on to the advanced category, right? This is not completely advanced. Some of these things are, but it will be better to know them. Like if you want to actually build a SaaS, like seriously, you should at least know the words, if not exactly how to do them. So let's look at the first thing. So the first thing is Git. Git is like a register, a timestamp register of whatever you're doing. So it's a good practice to use Git and GitHub. So I'm going to show you in this program how you can use it. So whenever you develop a new feature, you can use Git to save it. Just in case you make something bad happen later, you can restore the thing. So that's what we're going to be using Git. So CI/CD pipelines is the full form is continuous integration and continuous delivery. So when companies build complex systems, they have CI/CD pipelines, and I'm going to show you the CI/CD pipeline using an example image. So this is a pretty simplistic. Let's just see this. This is pretty simplified, right? So whenever you make a program, whenever you build some feature, there are a few things you have to do. And it's pretty easy to understand. Let's just see it, what you have to do. This is your SaaS, right? This is your SaaS. You make a feature. You're making a product here. The next step before you give it to anyone would be to test it, right? That's common sense. So you want to test everything that's working and what's not working. So either you can manually test the application, you can click each button, you can click each form, you can try to do each action manually, right? To see if something is broken or nothing is broken. And when the application is simple, it's fine. But when the application gets bigger, that's pretty stupid. Imagine you have a very big application. It has like 100 features. And then you add the 101st feature and to make sure nothing is broken, you will have to test the 100 features before. That's pretty stupid. So we have automated testing libraries, which we'll learn later in this course, which would be covered in the advanced section. It won't be covered in the normal section because you don't actually need it if you're building your first SaaS. If you're building a micro SaaS or even some kind of normal SaaS, right? Unless you're building a super big company, it's not necessary. It would be good, but it's fine. So CI/CD pipeline is basically automating this whole process. So let's look at each step. You make a commit. Here you can see you commit change, which is using the Git, right? You use Git, you add your feature and you click commit. You're done. Then a trigger build, right? So your application is built. This is not true for each of your programs. For example, if you don't need a build report, you don't want it, right? So this is kind of nuanced, but you have to run the test in each case. You run the test and see if nothing is broken. If everything is perfect, you deploy it. That's basically a simple idea of CI/CD pipelines. You build stuff, you automatically test it because testing every feature is stupid after some size, right? And imagine you deploy a change which can break the entire site. Imagine, let's take our example for our SaaS, right? So you have a SaaS, it's connected to an N8N agent, right? And you make some changes to the N8N agent. You're not adding a feature on top, you're adding it to the bottom, which basically means everything that's connected to it can break. If this is wrong, everything on top will break, right? So it's important to test it. And this is even more simple example, and this is perfect. You code, you build, you test it, you release it, you deploy it, and you operate and monitor it, and then you plan again and you make new stuff. So now you can see how this is perfect. You get an idea. Let me simplify this. You get an idea, you make it, then you click the build command or you enter the build command. Then this pipeline that you're going to build, it automatically does the testing, releasing, deployment for you. And then you just have to make new features and leave it to the CI/CD pipeline, which you once built, right? So now you understand this. The next thing is SEO. So you have your website and how the search engines perceive it is determined by the search engine optimization, which is the whole form of SEO. So to SEO, you don't have to use too much of your brain. So doing SEO is about following some guidelines, basically. You don't have to use your brain. You can use your brain in researching and finding keywords that you can use to rank higher, which is true for any social media or YouTube or whatever you're doing. But you get the idea. This is about robotically following some steps, which is you need to have a sitemap for your website. We're going to see that later, what it means. You need to have a file called robots.txt. So whenever Google or some other search engine crawls to your website, it knows what it means, right? So imagine if I enter YouTube here. So I'm just going to enter YouTube on Google. Now you can see YouTube and all this stuff. So the bots crawled it. You can define all what you want to put here for your website, but the bots automatically crawl it, and you can define it using SEO. You need a sitemap, robots.txt, LLMs.txt. Now we have LLMs and these chatbots, so they also scrape your website so they can get information. So you have to optimize it for it. Now, if you're running a blog for your SaaS, it would be extremely useful. Why? Because a lot of traffic comes from Google because they don't exactly know what they're looking for, so they enter a generic query, right? And if you rank on top for that query, you can bring in a lot of revenue. I know people bringing in millions of dollars in revenue simply from an optimized blog. And every site has it. For example, let's see Lovable, right? If you go below, they'll probably have a blog. Do they have a blog? Okay, there is a blog. There we go. We can see the blog page now. And they write blogs about what you can do with Lovable, right? So you can see how many blogs do they have. So this is going to be bringing in revenue for them from Google. Let's look at something, right? Let's see what exactly can we do. So let's look at this keyword, right? They have researched this keyword and made this the title. There's no Lovable here. So what I'm going to do is copy this word for word. And this is a pretty common query, right? Imagine if someone asks how to use an AI form builder to create secure login and sign up forms. This is a normal query. People want to know. So when they copy it and paste it here, if someone searches it, you can see that they go to Lovable. The Google have used some other websites, so this website is even ranking above Lovable. Probably it's older, it has better information, but now you can see. And imagine if I type this and I see Lovable. Oh, let's just go here. So I go to their website, and I might potentially convert, right? So it's extremely important. Everyone does blog. Every successful SaaS has a blog. Let's look at Trail. I'm going to go to their main website. I'm going to close the inspect element, and you can see use cases. They probably have a blog somewhere here, resources blog. And this company just spans blog, the AI written blogs. So they can get users from Google. You can just see they just spam random blogs. And these are pretty targeted. They're not random. They just have so many. For example, 15 viral Twitter campaigns for inspiration. It's not even about their product. They just wrote it. Why? Because people might see it. People might come on their website and they might potentially convert. So let's just Google it. Okay, so they're not ranking on the first page, right? Let's see the second page. They're not ranking even on the second page. But you can imagine people who search this and those who are on the first page, how much can they convert, right? So this website might be converting so much, whatever they're selling. They're probably selling some SaaS product as well. Exactly. So they're selling Instagram wall, Twitter wall, and they're selling this product. So you can make walls using this. And they have written the best blog. They have ranked for the best tags, best keywords. And I'm also going to teach you the black hat method. How do people actually build their blog faster? Like how do they build their ranking, and how do they get to rank at Google faster? All the dark practices they use. The next thing is that your blog post and your website should have tags, description, and metadata. So the crawlers and the bots that come on your website, they don't understand anything. Like they don't care. They're just bots. They don't exactly know what this is about, what the blogs are about. They don't really know. So what they use is tags, description, and metadata. So this is information that the bots use to find what's optimal for the user, like what to show. So imagine you have two blogs which are exactly the same, but underneath they have different tags, description, and metadata. So the bots don't just crawl the entire website and look at all the text. Like the bots read this, but reading this is not enough, right? So it uses additional data, tags, description, metadata, who else is linking to your blog, this, sitemaps, to determine what's best for the user who searches and how to rank it. So we're going to see how you can do that later in the course. And now I'll show you what exactly are these, which are like the outsourcing blog sites. So if you look at all these blogs, right? Example, if you look at Lovable, you might think this was manually made using HTML or even Next.js, but this is not a manual page. So what they do is, so you might think that they first created the heading, then they added the image, then they added the authors, then they added the subtitle, then they added the text, right? And then they add images whenever they need manually. But this is not how it works. And you can even look at the other blogs. There are more blogs. There's this blog, right? So they don't do this manually. What they do is use an external engine to do this. Now I'll show you. For example, if I come to the Tesla website and click on this, now I can see that they use a true call. You can see someone uses Strappy, someone uses something else, and you can see what exactly is each site using. So what these do is these are services. And in this service, what you can do is firstly, you can define a template. You can define a template that all your blogs will have a heading, H1. They'll have an image, like the thumbnail image. They'll have the date published, author, then there will be content. And the content will have images and all the other stuff. So, and then on your next app, the Next.js, your website, your SaaS, you can make a generic page. For example, you can say that this is a page which displays H1, image, then the date and author, then content. You can just make a generic template, and you can leave all these fields like dynamic, like in NA10 and all the stuff we see, that you can just leave it dynamic. So whatever data comes in here, it showed. So once you make this, you can use it for a million blogs basically. And this is where you define the semantics, like what is H1 and this, that. And then from an API, you can send this to your Next.js website. So you can send H1 to H1, the image to image, date and author to date and author, and content to content. And you will have unlimited pages from one. And you don't even have to manually code. So you can just go to their website, click add or press plus, and you can just add your H1. You can like edit like you would edit a visual editor basically. And you can add all your data and you can just press publish and it automatically comes to your website. And I'm also going to show you how you can do the SEO, the tags, description, the metadata, how you can do all this stuff dynamically. So you don't have to define it one time. So once you set up your blog, it runs on autopilot. You can just have these things running. You can manually add your blog or even connect these to another API. You can have your anything blog agent, right? And connect this blog agent to this API, and this API connects to Next.js. So a blog is auto-published whenever you want, and you can rank above, which is extremely important for you. Then you can have customer support and feedback. I think the spelling is wrong, but anyways. And then this is hyper advanced. We don't actually need it unless you're building a B2B SaaS, and advanced stuff. Just let me know if you want information on all of these. Then there's internationalization. So your website is available in different languages, the Tesla website. And here you can see, if you click on this button, and now you can see it is available in so many languages. This is basically internationalization and localization. And if you click this, it goes in another language. I'll show you how you can add this to your website as well, if you want to make an international website. The next thing is testing. I'm going to show you basic testing. And if you want more advanced, let me know. And I'll also show you how you can use emails. So what do I mean by that? So you can configure emails. For example, there's a service called Resend, which is pretty popular. So you can use Resend emails. So to configure whatever happens in your SaaS. Imagine you have some commands like person makes an account, person deletes an account, person joins via subscription. So for these things, you'll have separate functions which will run in the server like we saw here. But you can add one more line that send the email about this, which we'll do using Resend, email for developers. So whenever a person signs up, we can send a customized email. Whenever the person leaves, we can send asking like, why are you leaving? Whenever a person joins via subscription, we can say, amazing, great work. Hopefully you won't be disappointed in the product, right? So that's what we're going to be using for emails. And there are other use cases as well. For example, reset password. For resetting password, you need email if you're using the email password setting. So whenever the person clicks reset password, you send the link or the new password to their emails. All right. For receipts, you need emails. And DevOps basically means deployment. That's the easier way to say it. I'm going to show you how you can deploy your um, startup or SaaS on Vercel. And I'm also going to show you how you can deploy it on VPS. Vercel should be pretty fine. They have a generous free tier. And even if you have like few 100,000 users, this should be fine. But if you think that Vercel is overcharging you for, imagine you have a website in which there's a lot of server functions running. So Vercel charges for certain amount of server functions. And if your website is heavily server function focused, so it might be not worth economically. So you might move to VPS. That will be better. So I'm going to show you how you can do it. I'm also going to show you how you can make your website secure and how you can log, rate limit, and all that stuff. I'm also going to show you how you can track issues using Sentry. So whenever an issue happens on your website, so you get reported. And then we'll see how you can add analytics, Google Post Docs, and Plausible. So you can track where people are coming from and you can optimize your website. And I'm also going to be adding some of super advanced stuff. And I'm not going to be adding this unless people ask me to, but I'm going to add this just because knowing this is more common than this, then people might actually need it. And if you need anything else, let me know. So in this tutorial, we have seen the entire map of SaaS, how it works. Firstly, we saw how the front end works, the libraries and all that stuff. Then we saw the state management, which is an important part of the front end, right? And how different state is managed. I also showed you many examples. Then we saw authentication. What is the difference between authentication and authorization? Different types of authentication using JWTs or called JOTs and sessions. Then we saw databases, how we learned about SQL and NoSQL, the ORMs. And you can also, if you go without ORM, you just manually write SQL queries, which I showed you here. You just manually write these, to write many of these. That's super hectic. Then I also told you what basically is a server and how APIs and the books are different, how the server runs, form validation. We saw a bit about CI/CD pipelines, but I didn't talk about multi-tenant. So in some websites, there's multi-tenancy. What that means is you get your separate site, right? So if you sign to a website, how it will look like is you have, for example, x.com and there'll be a dashboard for you. But in some websites, some companies want to give you your entire different dashboard. Example, if you sign up for some big companies like Microsoft, you get their enterprise plan. So they give you your own special site. For example, Dorian.microsoft.com. I missed the spelling, but anyways. So they give you your special website. If someone else signs in, they'll say Dorian too. If Jack signs in, there's Jack. So you get the idea that they want to have separation of concern. They want to have separate for each person. So that's where multi-tenancy comes in, and I'll make a tutorial about it in the advanced section. Then we learn about SEO, how it's important, why it's important. We learn about internationalization, different languages, emails, testing, and how to deploy and analytics. So before we end this, let's also see how things used to be built in the past. Not super past, people still do it, but there's a front end where all your visuals are. Then there's a back end where all your server functions run, even though authentication is in back end. So for every single thing, here, these are just buttons, visual search buttons, but they have zero functionality. They are just hosted somewhere, right? They are empty on the inside, let's say. So whenever you click it, a REST API is sent and anything will happen with the backend and it sends you the response. This is how it looks, basically. And this was how it's done in the back in the days. And there were two separate deployments. So you would have to deploy it two times. Once the front end, once the back end. And you just communicate via REST API for every single thing. You click a button, it sends here, then it asks what to do, and it sends it back. That's how it was done in the past. Like every single thing, every single button, single element. But now it has changed. Now we have Next.js. What Next.js is it's the server itself. So Next.js is a server-side framework. So whenever you run a Next.js website, a server runs on the inside. That's what's happening. And whatever front end you see, the buttons, the pages, for example, even this is built on Next.js. But whatever you're seeing, it just runs on the data on the backend. It's running on the server, and the server sends some HTML. That's the difference. Earlier, it was you have so all the websites and entire web is based on HTML, CSS, and JS. And you see all these framework, Next.js, this, that, Vue, other JavaScript frameworks. All these compile back to JavaScript, CSS, and HTML. Even the Tailwind CSS compiles back to CSS. So you get the idea. All these things are library on top of this. So whenever the final build is going to be built, it will convert into these. So earlier we had one thing, the front end, which was HTML, CSS, and JS, right? And that contacts to the backend for every functionality. Now we have put two in one. Now you have this, and the server runs inside of it. So how do you display the front end parts? How do you display the buttons? So what you do is you define your page, and the server spits out the HTML, and the HTML is displayed. So whenever you click the button, so rather than having the separate stuff, it just sends inside and does the functionality and sends it back. So that's the difference between normal two separate deployment, front end, back end, and Next.js. And now let's look at our stack in this course. So in this course, we'll be using Next.js, Tailwind, and ChatCN for our front end. And this is basically a full stack framework. So this is for our front end, and Zoo stands for state management. For the backend, we'll be using Supabase with Prisma. We'll be adding Stripe payments. We're going to be adding our Anytime agents. We're going to deploy it on Vercel. We'll add analytics, email. We'll use Zod for validation, and then we'll also add we'll add minor testing. We'll actually not add testing on the 14-day course, the challenge. I think this will be too much for that for complete beginners, and adding security and all this stuff would be too much. So for that challenge, we'll not be doing all that stuff, and we'll not be adding Sentry and all that stuff. Logging is automatically handled by Vercel, so we don't have to handle it manually. So that's what we're going to do in our 14-day challenge. And you'll learn more about it in the next video, and you'll see what exactly are we going to build. And in the advanced section of this course, you'll learn all these things, everything. I'll teach you not just one auth library. I'll teach you Next.auth, the auth.js, and then I'll teach you better auth. I'll show you basically everything. I'll show you MongoDB as well. I'll show you Neon Tech with Drizzle. I'll show you different kind of tech stack. I'll show you 2-3 kind of auth tech stack. I'll show you 2-3 kind of databases and ORMs, and a few kind of validation libraries, Stripe, Pillar, different kind of these serverless blog services, and I'll also show you how to deploy on VPS and stuff. But on the 14-day course, we're going to do limited stuff. It will be super advanced. You'll learn everything. So you'll learn everything you need. This is all kind of a advanced developer stuff, or even medium to advanced, but you don't need all of this to build a successful SaaS. Most of these products, for example, this Creo website isn't using anything. They're probably not testing anything, and they're probably not doing all of these things because it's built in most of the times. So we're going to be building something better than Creo, to basically put it that way. And so so if you complete this course and you understand everything, this should be for complete beginners who are watching this first time, like you don't know anything about code. You might take a bit longer than 14 days. You might have to watch a few things more than one time to internalize it. But for the people who even are like 5 out of 10 of coding, who know these words previously, like you already knew, even if you kind of knew what Next.js was and you're just coming here, so you can probably complete all of this in 14 days. You'll also be provided code and support for building all of this. And for the advanced stuff, you can just learn it on your own pace. And even for the 14-day course, you can do it on your own pace, but I would recommend like showing some urgency, so you put more effort into it. So this is the entire map of SaaS which we saw now. I'll see you in the next video.